Hi, I'm Jared Friedman representing Code4Software, here to present the Finalist update for the Water Waste Warning System, the W3S, which was our entry for Samsung's Makers Against Drought challenge using the Arctic 10. Now we're also using the Arctic Cloud. So the W3S has been continuously improved since winning a finalist position in the Samsung Makers Against Drought challenge. While there have been numerous trivial upgrades, the primary upgrades involve the following areas. We created a modular 8-port extender that can easily be added to the Arctic 10 development board, and up to 4 can be supported. We added 2 of these port extenders, thereby increasing the number of analog ports from the standard 6 to 16, and the parts cost under $10 to do that. We upgraded the case to accept 16 RJ11 jacks instead of the 6 that we had before for 10 more sensors. We had to rewrite the vTracker sketch module to handle 2 banks of port extenders. We also created an Arctic Cloud custom device type and custom device for the 16-port vTracker module. Then we integrated the Arctic Cloud JSON data writing capacity to the vTracker module and thereby integrated the Arctic Cloud. We also created a code generator that generates vTracker sketch modules from database entries. We updated the server-side data logger to handle 16 data points instead of 6, and finally we created our first dashboard. The limitation of only 6 analog ports makes our solution potentially require multiple modules per government facility, as some city properties have more than 6 sprinkler or watering zones that need monitoring. Once a city had a W3S module in place, it could be used as part of a Smart Cities initiative because other types of monitoring could also be installed very inexpensively, as long as there were enough free analog ports. Things that could be monitored include air temperature, air humidity, air quality with particulates, air quality with smog, light pollution, and many others. Having more analog ports is critical to this, so this was the area we selected for improvement. By using an off-the-shelf analog multiplexer, 3 digital GPIO ports and 1 analog port turn into 8 analog ports. The specific unit used was a common 4051E chip, which is a 16-pin DIP package. First we did it on a breadboard, and then once we saw that it worked, we moved on to actual soldered port extenders on perf board. We did bank 0 and bank 1, each doing 8 ports, and we then created a 3D printed plastic support bridge that allows them to rest directly on the Arctic 10 development board. Bank 0 uses GPI pins 3, 4, and 5 for the signal, and analog port 0. The bank 1 uses GPIO pins 7, 8, and 9, and analog port A2. So we added the RJ11s, and the RJ11s carry 4 wires, but we're only using 3 of the wires. One is for positive, one is for negative, and the other carries the signal. A schematic is presented here that shows the various power connected and the pins that are used on the 4051. The 4051 modules that we made allow us to put up to 8 of them on a currently configured 0.5 version of the Arctic development board, which would give you 32 analog ports. So that's pretty good. We don't have any cases that will support that many ports, but we can always make one. For the software side, the Arctic 10 vTracker module runs a .elf file, which is generated from Arduino sketch code, which is created by our database server. We do plan to use Resin.io. Actually did a full investigation of Resin.io up into including creating an account and getting a actual image to put on the Arctic, but the truth be known, it was a little scary to have to totally put an image over the operating system, blowing out the entire contents of the operating system, not being sure whether or not I could recover it should it not work, not being sure whether it would actually work. Too much risk, too few devices, too close deadline, didn't want to do it. After it reads all the ports, the 16 ports, through the setting of the various pins on the 4051s, it will go ahead and prepare the data to send it as a query string GET to the vTracker servers and Code4Software servers, and then we'll prepare it as JSON data and send it to the Arctic Cloud with a RESTful JSON call. And we've already written a bunch of data to the cloud, which can be seen here. And you can see that when we run it, produces a nice amount of data. When we turn it off, it's this big empty gap. So this isn't actually running 24/7 right now, it's just testing, development, prototype, but it does in fact work. We use the MVC architecture, and it requires a certain file structure. It uses its file structure sort of to work with these black boxes with AngularJS and with the MVC internals of Microsoft ASP.NET 4.5. So we followed their directory structure pretty much industry standard and kept everything pretty much industry standard, easy to understand for somebody coming in to develop on it. And then we finally got to do our new dashboard. So we integrated a bunch of JavaScript charts, various different charts from different technologies, different companies. We sort of put them all together, what we sort of enjoy, and we're still working on it. We still haven't figured out exactly which KPIs we want to display, but we just got the pattern working, and it's available for you guys to look at live on the website right now at vtracker.com. Just a final note that this is the device that's been running the entire time. You can see in the background the data has been updating, it's still updating, and the data actually, I'm going to go ahead and update the Arctic Cloud now. It's newer and just kind of creeped up, but yeah, there's the data, and I think actually you can do 5 minutes, or 30 seconds, sorry, 1 hour. There we go, and there's the data that's been coming in while I've been talking, and it all works, and I'm happy and excited to show you guys in our actual technical review. Thanks very much for your time. Have a great day.